This is 8th grade math, Unit 1, Lesson 3, Grid Moves. We're going to start out with a what do you notice, what do you wonder? So take a look at the image that's there and type in one thing that you notice and one thing that you wonder. All right, and there's really not a right or wrong answer, right? Because you can notice or wonder just about anything here. As long as we're talking about this image, we want to have our math thinking caps on. When I'm looking at this image, I notice that it looks like a grid. It looks like it is made up of equilateral triangles. I know that a triangle has to add the interior angles to equal 180 degrees. And if these are equilateral, then I can do 180 divided by 3. And I know each angle in these triangles would be 60 degrees. I wonder if we're going to be graphing on grids that look like this or what this is for. So whatever you noticed or wondered, make sure you put that on task 1. When we come on to task 2, it's going to teach us just a little bit about our different types of movements. So in our last lesson, in lesson 2, we started talking about 3 main types of movements. We had slides, we had flips, and we had turns. So the mathematical language that we want to be using there, those types of movements are all called transformations. So anytime we're moving a figure around, we are transforming it. So a transformation is an operation that maps an original figure. The original figure is called the pre-image onto a new figure, which is called the image. So we have the pre-image is the first figure and the image is the new figure. So when we look at the example on the graph right here, we've got a triangle ABC, and then we've got this other triangle that has these little marks, right? It's still an ABC, but they've got these little apostrophes or what we call prime symbols beside them. So on this graph, triangle ABC is the pre-image. It's the original triangle. And triangle A prime, B prime, C prime is the image. Those little prime symbols are what help us tell the difference. So anytime we see those little prime symbols, that lets us know it's like a copy. Okay, so it's a copy of the original triangle ABC. It's kind of like when you make a copy of a Google Doc or something like that, and it says copy of in front of the title. That's basically what's happening here, right? This is a copy of point A, a copy of point B, and a copy of point C. All right, so transformations. When we start thinking about what transformations can do to a figure, transformations can change the uh, placement of the figure, right? If we're sliding it around on the graph, we're changing the placement. It can change the orientation, so it can change which way it is facing, right? The orientation. Or some transformations can even change the size of a figure. We haven't seen any of those just yet, but we will get into some of those that change the size of a figure. Okay, so there's 4 types of transformations, 4 main types that we're going to focus on. The first one and the one that we have an example of right here in our triangles, we're not changing which way that triangle is facing. We're just sliding it around. So that one is called a translation. Translation is like a slide. So we can see that here, right? We took this trapezoid, we slid it over to the right and down just a little bit, and then that created this new trapezoid. Another type of transformation. The next one, next to slides, in that first lesson, we talked about turns. Well, we call those rotations, right? So there's rotations. That's where we're turning a figure. We're spinning it. And then in lesson 2, we talked about those flips or those mirror images. We call those reflections. Just like when you look in the mirror, you see your reflection. So it would be like a flip, and you can see example here, we can flip it over this line of reflection or this line of symmetry. And then the last one, the one that we have not seen yet, would be a dilation. Dilation is where we're actually changing the size of the figure. We're making it larger or we're making it smaller, enlarging or shrinking it. We'll talk about dilations in Unit 2. So for Unit 1, we're mostly just going to focus on the three that we've been discussing so far: the rotations, the translations, and the reflections. All right. So coming on back to our GeoGebra lesson, we are going to look at some translations. So we have some directions here, a little bit of vocabulary. It says follow the directions below each statement to move the figure. Use vectors to show translations. A vector is a quantity that has magnitude, size, and direction. It's usually represented by an arrow. So in our example that we had here, right, our arrow represents our vector. It's showing which way we're moving. Okay, so we're going to translate triangle ABC so that A goes to A prime. This looks like we are working on, the instructions are on task 2, but where we're actually moving the figure around is happening on task 3 right here. Okay, so we're going to select the vector tool. That's this tool right here. It says we want to translate it so that triangle ABC, so that A goes to A prime. So I'm going to select the vector tool. Step 2 says click the original point A and then the new point A prime, and we should see a vector. So I have my vector tool selected. I'm going to click the original point A and the new point A prime. Yep, and sure enough, there's my arrow. Step 3 says select the Translate by Vector tool. So it gives me a picture of what it looks like. It's the one right next to the Translate or the Vector tool that we were just looking at. So we're clicking on Translate by Vector. Step 4 says to click on the figure to translate and then click on the vector. So I want to translate this triangle. So I'm going to click inside of that triangle. Then I'm going to click on the vector. So I'm going to click on this arrow from A to A prime, the vector that I just created there. Okay, and when I do that, it creates my new triangle, A prime, B prime, C prime. All right, so we have a spot where we can type some stuff here. When we look at our translation, I just want you to, let's say that a translation, right, or a slide changes the position of the figure, but not the size or orientation. All right, so translation slides, they just change where the figure is located. They don't change which way it's facing. They don't change the size of it. These are still two congruent triangles. All right, so when we come over to task 4, you're going to do a translation. This time it says to translate triangle ABC so that C goes to C prime. So remember, we're going to click on this vector tool, right? So this button right here, the vector tool. This time we're going to go from C to C prime. So I'm going to click on C. I'm going to click on C prime. And there's my vector, right? I've created that little gray arrow right there. Whoop, let's undo that. I just clicked randomly. We do have these handy undo buttons right here. So if you ever accidentally click on something like I just did, just click on the undo button. All right, and then I want to click on my translate by vector. So I'm going to select the figure, right? I'm just going to click on my triangle, and then I'm going to click on that gray arrow, the vector, and it translates it so that C goes to C prime. Now, I noticed that to get from C to C prime, I would need to go over to the right 2 and up 1. To get from A to A prime, I would have to go over to the right 2 and up 1. To get from B to B prime, I have to go over to the right 2 and up 1. With translations, we are moving every point the exact same distance and the exact same directions. Okay, Now we're on to a rotation. So this is going to be on, it looks like task number 5. All right, so we're going to rotate triangle ABC 90 degrees counterclockwise using center O. That just means we're spinning our triangle around center O. And we're going to be spinning it. It says counterclockwise, so that's opposite from the way the hands on a clock go. So we're going to be spinning in this direction around point O. All right, so step 1, select the rotate around a point tool. So it gives me a little picture of what it looks like. I'm going to click on that picture. It says on step 2, click on the figure to rotate, and then click on the center point. So I want to click on my blue triangle, and then I want to click on that center point O. A dialog box will open, right? Step 3, a dialog box will open. Type the angle by which to rotate and select the direction of rotation. Well, it said to do 90 degrees and counterclockwise in our instructions. So let's make this say 90 degrees, and counterclockwise is already selected. Okay, so I'm just going to scroll down a little bit so I can see and click OK. All right, and my triangle ABC has been rotated 90 degrees counterclockwise. Here's where my new figure ends up. So I have the blue is the pre-image and the green is the image, right? The before and the after. Okay, on task number 6, it says we are going to reflect our triangle ABC using line L. The instructions here are on task 6, but the place where we're actually doing our reflection is going to be on task number 7. Select the Reflect About Line tool. Okay, so I'm going to come over here. I can see the Reflect About a Line tool. It's the 2 little dots with the line in between it. Looks like one dot was reflected over that line, so I'm going to click on that. Step 2 says click on the figure to reflect and then click on the line of reflection. Well, the figure is the triangle, so I'm going to click on the triangle, and then it says click on the line of reflection. Well, this dotted line here is labeled line L. It's a cursive L. I'm going to click on that anywhere along that line, and that blue triangle has now been reflected over line L. All right, so again, there's a little box where we can type some information here on task number 6. I'm just going to type that a reflection, which is a flip, or we've been saying a mirror image, right? A reflection or a mirror image, moves each point the same distance it was originally from the line of reflection. So I notice in my diagram, point C is one space over to the left from line L. And the new point C, C prime, is one space to the right from line L. Point B, the original one, was 3 spaces over to the left from line L. But B prime is 3 spaces to the right from line L. So it's the same distance it originally was from the line of reflection, just in the opposite direction. All right, so that's going to be one of the key features of doing a reflection. We want to see how far away each point is from that line of reflection, and then make the other point be the same distance, just in the opposite direction. All right, so then we have a rotation. This one is moving on to task number 8. Notice the grid has changed, right? We have our equilateral triangles instead of our squares. Well, if I'm rotating something 60 degrees, remember these equilateral triangles each had interior angles. Each of these little angles here are going to be 60 degrees because 60 plus 60 plus 60 gives me a total of 180. Okay, so I'm going to rotate, right? I want to rotate it using a center at B. So I'm going to use my rotate button. Remember, rotate around a point. I'm still going to start by clicking on my object to rotate. So I'm going to click on my, it's like a trapezoid here. And then I'm going to click on B because that's the center that I'm trying to use. Okay, so then it asks me to rotate it 60 degrees. Counterclockwise is already selected, and then I'm going to click OK. Now I want you to notice those corresponding segments, right? This side AB and this side A prime, B prime in the new figure, those corresponding sides, the sides that go together, are 60-degree angles from each other. And I can tell that pretty clearly when I use my equilateral triangles for the backgrounds. All right, on the next task, I believe this is task number 9. This time it asks you to rotate the quadrilateral ABCD 60 degrees clockwise, but using the center at C. So I'm going to click on my rotate around a point, click on the object, then click on the center. This time I'm clicking on C. I want to rotate it 60 degrees, and this time I'm going to select clockwise because that's what the instructions say. Then when I click OK, ooh, this one looks different. So I've still rotated 60 degrees. This time I've gone clockwise, and it's caused my image to overlap my pre-image. Okay, now we're practicing a little bit with the reflection. Even though I've changed the grid to the equilateral triangles instead of the squares, the reflection is still going to move each point the same distance it was originally away from the line of reflection, just in the opposite direction. So I'm reflecting. I'm going to click on the reflection tool. I'm going to click on the image, and then I'm going to click on the line of reflection and just anywhere along this line L. Okay, so I can see that I've got cut exactly through the middle of this triangle, if you will, and I cut exactly through the middle of this triangle. The same distance, just in the opposite direction. Same thing with my original point D and the new point D prime. Same thing with B and B prime, and the same thing with A and A prime. Same distance, just the opposite direction. All right, a translation. So this is task 11. I want to use the translation tool. So if I'm going to translate it, it says we want to translate the quadrilateral so that A goes to C. So the first thing I need is my vector, right? The vector is the arrow that's telling me where to translate. So if I'm going to translate it, I'm going to click on the vector tool. I'm going to click on A. And then it says we want A to go to C. So then I'm going to click on C and create my vector from A to C. All right, now I'm going to click on my translate, the translate by vector tool. I'm going to click on the object, and then I'm going to click on the vector. So I'm clicking on that arrow there. All right, and we can see that every point has been translated in the same distance and direction as that original vector. And if I wanted to, I could go and I could create the vector from B to B prime, and I can see that it's the same distance and the same direction as the original one. It turns out if I do that for every point, from the original point to its corresponding point to the new point, then those vectors are all going to be the same length and they're all parallel to each other. All right, so coming on to, this is task number 12. You're just going to try out some of your own translations, reflections, and rotations. I'm not going to do this part for you because I want you to experiment a little bit with your tools up here. I do want you to make sure that you try out at least one or two of each of these types of transformations. On task 13, it's going to ask you to tell me the name of one of the polygons that you transformed and the transformation that you did. So you would say, this was like I transformed a rectangle and the transformation was a translation, or I had a triangle and I rotated it 90 degrees clockwise, etc., things like that. Okay, on task number 14, you're going to predict what's going to happen when you transform it. So this goes along with task 13. You're going to tell me, I think that it's going to look the same. It's just going to be turned on its side. Or I think that it's going to be the same position or the same orientation, so things like that. You're going to tell me what you predict it's going to look like. All right, and then on task number 15, I know it says challenge your partner. If you're doing this from home, you're just going to tell me what you learned from this lesson.